All right, I think it's time to start. Last time we did something related to 3D printing, but not 3D printed directly. I guess we used a 3D printed pattern, but we did some metal casting. It came out okay. We didn't take a lot of time and effort to make it really nice, so it was proved that you can do some metal casting with relatively low equipment investment and using 3D printed parts as patterns. A 3D printed part as a pattern is pretty normal. That's not a difficult thing to make the leap to assume you could do that. Normally patterns would be a little more smooth than the one that we used, so we just took it straight off the printer and used it as the pattern for the sand cast. That's not ideal because even in ours you could see where some of the sand that was supposed to make the mold came out with the pattern when we went to remove it from the sand. But it does work. It is a way to get metal part, the actual metal. Now it's still it's not like aluminum or steel. We use pewter, but it's a low temperature metal, so a low melting point temperature metal. But you can do that, so that's something you could do. Versus the route of trying to actually 3D print metal. I do have some of the virtual foundry metal, and maybe we'll try to do that, but it's not an easy process. And so printing it is one thing. That's hard enough by itself just to print the material, but once you print the filament that has, I don't know, it was like 90% copper and 10% binder plastic. Once you print that, then you still have to get all that plastic out of there, and so that process isn't something we could just do right here. So I don't know, we might work on that, but it's not something that you're going to do generally at home, but you can try. What we're going to do today is, for a while we have had our 0.8 millimeter nozzle in here, but we haven't done anything with it. It still doesn't even have the filament loaded in there. It's still hanging up here. So I thought we would set up our slicer and do some test printing on the 0.8 millimeter. I also have a couple of things over here that, depending on timing and how things time out, I've got this, which is just a box, but it is containing, this one is I think this is the light bar. Yeah, so this one's a light bar that will go at the top of your printer, kind of mounts where the top of the the frame, it mounts on that and has an LED light that shines down on your print. So kind of useful. It does help you see better, particularly if you're trying to take any sort of time-lapse videos or anything like that. It gives more light on the thing. Relatively straightforward, and I don't think it's very expensive. Let me look and see. I meant to do that and I forgot to look it up. See if I can find. Here we go. That one. So it's this guy right here, $18. So apparently it's on sale right now. This is kind of what it looks like. Looks like they've got it mounted on the back side. Maybe I usually mount it on the front side, but mounting it on the front side does put it right over the extruder, so it casts a shadow. Maybe that's why they put it on the back side. I don't see any better pictures of it in action, but it's just a little LED bar and some brackets, and it'll wire into your motherboard. So we have that maybe we put that on. I have another deal over here that would be an upgrade for our printer. Another black box from Creality. This one is the I don't see the name. Oh, it's on here. This is the dual axis for the Z. So let me show you what that one is. Ender 3 Dual Z. It's also not terribly expensive, $30, and you get a back. All right, there we go. Had a little disconnection, reconnection issue. So This one would add, and you get a new Z-axis rod, some hardware, mounting bracket, top and bottom. Oh, actually, these are guides for the tops of both Z-axes. What this does, and a wiring loom. What this does is, let's see if there's a picture that kind of, this one might kind of explain it right here. It's going to add a second Z-axis to your printer. So currently, you've got one Z-axis on, let's get this stuff out of the way, on this side of the printer, this side over here, behind this frame upright, and it's driving the entire Z-axis up and down. This side is really just held because there are 3 rollers, one inside there and these 2. So you could, now this one's actually pretty tight. You could have a little bit of wobble in there on this side because you're only driving from that side over there. I've got this one set pretty well. Like, there's a little bit, but not really any. But if you have trouble, or you just don't want to deal with the fact that this side of your printer is really floating, it's not driven by anything other than it being connected over here, and you want to shore that up. In fact, right here I can tell that this wheel's not doing anything. This wheel is kind of off. It's the one up here. It's not touching the rails at all. So I'm not perfectly aligned, but I don't have a lot of slop in the beam across there. But if you think you do and you don't want to deal with it, one way to solve that is you can just add a second Z-axis. So I lost my picture. There we go. Basically, it's the parts in that oval circle right there. And that way, what happens is these 2 Z-axis motors down at the bottom get wired together. You don't have to do any like soldering or anything. They give you a little wire loom that basically one plug goes to your motherboard like normal, and then it splits into 2 plugs, one for each of your Z-axis motors, and they will both drive at the same time. So you don't have to worry about syncing them together or anything like that. But now there's no way that you'll have any of this slop, this little bit of slop right here. I don't even know if you can see it's moving. Now you can. Because they're both attached to Z-axis screws, lead screws. So it's not a difficult upgrade to do, but it is one that pretty easy, and it definitely has an effect, particularly if you're not able to get this set very well. One thing that you can get this really tight to where there's hardly any wobble at all, but the thing that you run into is if this upright and this upright are not really parallel, you can actually create a binding effect where it is difficult for the Z-axis beam, the whole beam, to move up and down. Let me see if I can draw what I'm talking about there. Here's my pen. And I'll show you what this can look like. So if you have, let's just draw our beams, or well, the upright parts. So let's say that this is one side, and then, whoops, I didn't mean to draw that. I meant to grab that one so we can move it. There we go. And the other one's over here, right? And you've got your axis with your extruder on it goes across here to make it thinner. Wonder if there's a way to fill that in. Probably is. I don't know. There's probably some way to fill that in, but that I don't know. I don't see any obvious way to do that. Anyway, imagine that's filled in. So this normally goes up and down, driven by the axis on the, well, depending on which side you're looking at. If you're looking at the printer, the left-hand axis. But if this, I'm going to make it extreme, one of these is not parallel to the other one. Doesn't matter how they're not parallel, but the 2 uprights, if they're not parallel, and you're trying to move this guy up and down, then it's going to bind. It's going to want to bind somewhere, because you're either going to have it really really dialed in down here, but then as it gets further and further away, it's going to be sloppy, or it's going to bind or something. A lot of times how this shows up is you're printing your part. Let's say that this is the part you're going to print. We're going to print in green filament here, and we're going to print something down here. So here's our print bed. Well, since it's heated, we'll say that there's our print bed. So what'll happen, your little part down here, how this shows up is there'll be a line wherever it's wanting to bind that just doesn't look like all the others, because it's trying to print, and as it wants to move up to the next layer, it can't, or it doesn't move a full step, or it doesn't move correctly, and it kind of prints the same layer in the same spot again, and eventually it will free itself. It will skip several what would be steps when it does want to move up, and it'll leave this little gap. So if you have a weird looking line at the bottom down here that just doesn't match all the others, maybe it's squished, or maybe it's just kind of it just doesn't look right, it's possible that you have your two uprights not parallel to each other. Like they're not going to be as extreme as what I've drawn here, but they're just not parallel. So try it. One thing you could just do is measure the distance at the top across and measure the distance at the bottom across, and see if they're parallel or not. Now you could still have parallel and not vertical, not perpendicular to your print bed. They could be skewed. That's another thing. I actually have had a printer that it took a while to trace that down, but my parts were they just wouldn't fit. I never could get them dialed in. They were supposed to interface with another part, and they just wouldn't fit. And I finally printed two rectangles, just rectangle columns is all I printed. And then when you put them together one direction, they fit. And then if you mirrored one and put it together, you could see that, oh no, these parts are skewed. And they weren't skewed a lot. And by skewed, I mean like they would print, again, this is exaggerated. They'd print like that shape when they were supposed to be, perfect rectangles. They were supposed to be that shape, and they would be skewed. And they can skew in different directions. Like you could have the uprights are skewed to the left or right, but they could also be skewed front and back, and you end up with those are harder pieces to track down. But if you're having fitment issues, you print something that's supposed to interface with something else and they just don't fit together, one thing that could happen is your axis that's holding your Z print head, it's holding the Z axis for these printers, but it's moving in X. Those uprights could be skewed in some direction. Maybe they're parallel to each other and it moves fine, but they're not parallel and perpendicular to your print surface, and it will print parts that are skewed. So if you're printing like little minis or something like that don't ever actually have to plug into anything, then you don't really notice it. But if you're printing stuff that has to bolt to something else or fit into a slot or something like that, then it could be that that's an issue. So those are some issues that can happen when your axes are not perpendicular to your build surface and not parallel to each other. They're not square with the system. But it's hard to track down that. So one thing you could do, now this won't necessarily adjust for all of the skewedness, but it will help with the potential binding, and it'll help with the slop that you might have in here to add the second Z-axis. So a lot of printers now have two Z-axes. This is a relatively straightforward thing to do, not terribly expensive. You get all the pieces that you need to do it, and it usually takes, I don't know, maybe at most 30 minutes to do. I don't think it's a terribly long thing. You might go a little bit slower if you've never done it before, but all you end up doing is You relocate the power supply, and all the power supply does is it just moves backwards. So it moves that way 2 inches maybe, and they give you a bracket to do that. And then you do have to take this apart. So there's a little bit involved in doing that, a little bit there. And then you have to open up down here, which we're already open because I never have closed it up from putting on that CR Touch. And you have to plug in your Z-axis. There's already one plugged in. You unplug that one and replace it. So it's not terribly hard to get going. The probably the more difficult part is if you want to clean up your wiring and actually route it through the correct way versus what we did here, just put it through the top. All right, so those are some things. If we get some time later in the stream, we'll do that. But right now what we've got is we've got a new nozzle in here, which I just realized I need to turn on my connection to this guy so that we can actually talk to it. And we need to turn it on so that it is powered, because we need to do some print testing with this guy. So we need to load some filament. I'm going to heat it up and load in. I guess I'll load in this. This is just white PLA. It doesn't really matter what we load into it, because we're not printing anything in particular. Let me find some clippers that we can use to. We'll never get that loaded in there. So let's fix that up. So we'll just cut that. We need to heat this nozzle up. Well, not last time, maybe it was 2 times ago, we replaced this nozzle on the stream. So we've done that twice now, in really early one and then maybe 2 classes ago where we replaced the nozzle. If you want to go see how to do that, I've put it all back together. We did the hot tighten on it so that it should be not leaking, hopefully. And it has a 0.8 millimeter nozzle. It's one of these. So it's one of these little guys. These are the nickel plated brass nozzles. So that's what's in there right now. We took out a nickel plated brass nozzle just like that before, but I don't know that we ever did a PID tune on it. So that's probably something worth doing. Let's go ahead and get it heated up to accept some filament. So I'm just heating up the nozzle. Let's see. I'm looking for the PID. Yeah, here we go. Since this one's running in Clipper, I don't think I have a PID tune option over here. Setup. Oh, I do have one. All right. So I can do it right. I can do it from the menu. So a lot of times you do. Oh, my camera froze again. Hold on. Let's see. That should be this guy. All right, we're back moving. It didn't really matter. There's nothing on that camera other than me. So I do have one over here, and most of your printers also have in your setup or calibration or one of those, you have a option to PID tune from the menu, and this one does too. So before we do any of our slicer calibrations, I am going to do this tune. It doesn't take very long, and let's see if we're up to temperature for putting filament. Yeah, we're close enough. All right, so let's. You don't have to have filament in here to do the PID tune, but I think it's more realistic. So there we go. And let's just tune the hot end PID. Now I'm going to assume. Okay. It didn't tell me much what's going on over here, but it did over here. And it's under my picture. It's under my picture. So let me move that guy temporarily out of the way. So this little blue line of code right here, That's the command in Clipper anyway for doing a PID tune. So you can, oh no, that's not it. That's setting the temperature. So it didn't actually send the code here, but you can see, I think we can see the PID tune happening over here, and it looks like it is going to 205. So I don't know if you happened to be paying attention to this number, but it had dropped down. You can see it in the trace over here. It had risen up, dropped down, risen up. That's it cycling. I don't know how many times it'll cycle, because on my menu here I didn't get any options on the values that it's going to use, but apparently it's going between 205 and 210 are the two numbers I've seen as targets here. Or maybe it goes down below that, I don't know, because it was at 200. And so what it'll do is it'll cycle heating, cooling, heating, cooling, heating, cooling a number of times, usually at least 3. This will probably do 6 times. I don't actually know. We'll count them in a minute. And by heating up and cooling down, it is collecting data on how the system, the combination of the thermistor, the heat block, the nozzle, the heater, obviously, how they work together to respond to input changes. And it is going to take that data. See, like right now, the current temperature is like 217, so it's like going way higher than the target. I'm not sure if it's honoring this target or not, or maybe it's not updating the target all the time because it went way higher than that. But that's what you're trying to avoid, is trying to avoid way overshooting your target and way undershooting, overcorrecting when you overshot your target. So I don't think these target numbers here, they are changing, but they don't look like representative of what's going on here. But the whole idea for the PID tune is to more stably react to input changes for temperature in particular. You can also do this for the bed. The bed doesn't have as big of an effect on the prints, but it can have some effects. So it looks like we've done 4 cycles and we're on another one. And I assume it's going to do 6, but it didn't actually give me that option. If we were typing in the G codes directly, we could tell it the target temperature that we wanted to try and hit, and we could tell it the number of cycles that we wanted it to do. Alright, so it finished, and it gave me, here are my, it didn't tell me what my old, actually I can look them up in here, but I've got P, I, and D, so these K values are the coefficients for proportional, integral, and derivative controls. Yeah, bed PID does take a lot longer, you're right, because the beds just heat slower. So they do take a lot longer. I'm not going to do one of those right now because we might be here a little bit longer than we'd want to, looking at it cycle back and forth. It does the same thing, just it is slower. So the save command will update the printer. Well, let's type save config. On the if you're doing Marlin G code, there's a G code command for saving your values. So M500 is to save it. Let's see if it actually put. Oh, all right. So the save command forced it to restart. Let's see if it put those values, 22.9, all that, in our file. So if we go to our machine, we can look at the printer config file. This is, again, this is a thing for Clipper. So Marlin is a, you can't just go in there and look at these like this. You can see the files, you can see the values for your PIND. They usually will show up on your interface screen on the printer. Alright, so yes, down here at the bottom, there's those new values down there. So we're not supposed to edit them down there. We could, but we're not. So this is where it automatically generates those. So we'll save that. Alright, so we have PID tuned the nozzle. We probably didn't have to do that because we didn't drastically change the nozzle. We have the same type, same materials. If we had gone from brass to hardened steel, for instance, then we definitely need to do a PID tune, because those are very different thermal conductivities for brass versus steel. All right, so we've done that. Let's go to Cura. I've got Cura going here, and let's set up for trying to get something to print out of this 0.8 millimeter nozzle. Oh yes, that I keep showing y'all, like, because this printer is running Clipper. It is, some of the newer printers run on a system like Clipper, or like their branded version of Clipper. It is much simpler to do firmware level types of changes in Clipper than it is in Marlin, because you don't have to recompile and dig out a line of code from thousands of lines of code in some configuration H file. So it's much easier if you're doing that kind of tinkering. Plus, it has some relatively useful features. It might be worth it for one of our, this printer already does have Clipper, but it might be worth it for me to go through how can you put Clipper on your printer if you want to. It does take some hardware, so you do have to have Raspberry Pi or something like it. So we're running this little Raspberry Pi. This is just a 3B, I think. 3B plus probably. Now this little shield on top, you don't have to worry about that. That is just a cooling shield. Looks like my main camera keeps freezing up on me. I don't know why. Not that it matters too much, but it's annoying me. So you do have to have something like this to run Clipper, unless your printer already had Clipper on it. But we can probably walk through that one day. We have maybe 10 or 12 classes left. All right. We've got Cura. So first thing we need to do is we need to tell it that we are no longer using a 0.4 millimeter nozzle. Now we're at 0.8. And each of your slicers is going to handle this a different way. So Cura is not the one I actually use the most. I actually use the one that is either called Orca Slicer, so that's kind of the one that you can just download, or if I'm using the Bamboo printer, the Bamboo Slicer, which is Orca's built off of that. Both of those are built off of like Prusa, and Prusa's built off of Slicer. So there's this all like lineage of slicers that a lot of them are built off the same thing. But Cura is built by Ultimaker. I don't know if it was built off of any other slicer or if it kind of started its own line or not. But a lot of people use Cura, so that's what I'm using for the class for the most part. And so in the current version, this is 5.10, I think. I don't even know if it's the most current version. You click right here and you tell it, oh, I'm using a 0.8 millimeter nozzle. And then it'll tell you, are there some changes? These are just printing changes. We will, let's see, currently, let's discard those. So we'll kind of go back to the default. And then this is a PLA that I have in there. So if you have different materials, a lot of, well, not all, but a lot of brands of material are in here. Most of the time I end up having to be on the generic one though. Orca, yes. Yeah, Super Slicer, I forgot about Super Slicer, that's another good one. Prusa, Super Slicer, Orca, all of those are built off of one that's called Slicer. But it's Slicer with like a 3 for the E. So they all have similar features, but they look very different. Alright, so that handles the basic thing. We've got a 0.8 millimeter nozzle. There probably are going to be some changes we need to make over here. So, for instance, it put in, I don't know if it put this in or if this is what the last thing I was printing at. Probably it changed this. So our layer height. One of the reasons that you might want to put a larger nozzle is because you're trying to print big stuff and you don't want to take forever with thin layers. So with a FDM printer, there's a general rule of thumb that you can print layers that are as thin as 25% of your nozzle diameter and as thick as 75% of your nozzle diameter. Now you can go outside of those ranges and do thinner or thicker, but it just takes a little extra tuning. But the safe zone, the easy zone, I guess, 25% to 75% of your nozzle diameter, those layer thicknesses are pretty easy to do. Yes. So I'm going to go and say that we want to do as big a layer as we can. So that's going to be a 0.6 millimeter layer. Yes, the slicer with the 3. Tom Sandlander, I think that's his name. He's very straightforward on the pronunciation, and he says slick 3R because that's what it literally spells. But I think, I assume most, and he too assumes the intent was for it to be slicer, but be cool, because it had a 3 in there. So now we're hopefully going to get some 0.6 millimeter layer heights. The other thing that you can think about doing, now this one has already reduced it, is you might have been trying to print stronger parts. The easiest, or not easiest, the best way to get stronger parts with the FDM printer is just more walls. You can raise the infill, but sometimes the infill is not really adding much strength. I guess until you get to like 70% infill or whatever. But walls are directly going to give you more strength. Now that we're going to be printing with walls that are 0.8 millimeters thick or thicker, a lot of times, I don't think Cura does this, but some of the other slicers will actually do like 120% of your nozzle diameter as the line width. Cura defaults to just whatever your nozzle diameter is, that is your line width. So if we put 2 walls, suddenly we've got 1.6 millimeters of wall thickness right there. That was 4 walls before when we were on the 0.4 millimeter nozzle. So you don't have to use as many wall line counts, perimeters, to get the same thickness of wall that you were getting when you were printing with the smaller diameter nozzle. So that'll speed things up, because generally walls print half the speed of whatever you set as your printing speed. That is one thing. You may have to, depending on how fast you were printing before, you may have to actually slow down your printing speed. You'd have to test it and see. I don't know if we'll test that part today, but suddenly you are asking your printer to melt and extrude a larger volume of filament every time, because we've got thicker walls, thicker layers. So that's more filament coming out of the nozzle per second. So the volumetric flow rate has increased, and you may hit the limit of being able to melt filament fast enough. So there are some things, if you're bumping up against that limit, there are some things you can do. One of them is not these are just nozzles. One of these is, and I have not done that to this printer, but you can go to a higher wattage heater. So I think most of these printers start with a 45 watt heater. This one is a 60 watt heater. So you can suddenly just put more heat energy into the hot end faster. No, I don't think you'd have to slow it down 50%. How much would you need to slow it down by? Probably like, if I wouldn't slow it down at all at first. We would need to do a flow test to see, well, what is the maximum that we're at? If I slowed it down, it'd be like 20% or something like that. But only if I was having print issues, like it looked like I was under extruding. It wasn't able to generate enough filament coming out of the nozzle to do whatever I was asking it to do. Generally, the unmodified stuff can flow somewhere in the 10, what are the units on that? I can't think of the units for it now. We'll have to look in Cura and see what the units are. I actually wouldn't slow it down at all at first, unless you had really bumped it up to like you were doing 120 millimeters per second on something like this Ender 3. Then you might have to slow it down. I would print somewhere around 70 millimeters per second. That's where I'm going to start and see where we're at. So this just directly puts more heat into the hot end. So that's one thing. It's $8. You do have to be careful. So not all of your FDM printers are the same voltage. So some are a 12 volt system, some are a 24 volt system. So you do have to match the the 24 volts here with whatever your system is. So Ender Creality stuff is 24 volts, but not all FDM printers are 24 volts. So do make sure that you get if you change the heater, make sure you get one that matches the voltage of your system. The other thing you can do is, well, now we've already changed our nozzle. Did I close it? Let's find a Bond Tech. Let's see if I can find one. These guys. So these have an interesting inner geometry. So that's a 0.6 millimeter nozzle, but right beside it there's a 0.8 over here. So not only is the nozzle diameter larger, but inside, I assume you can see, there's this little kind of like 3 different channels. What this nozzle, the idea for this nozzle is that as your unmelted filament, although it's softened at that point because it's at the top of the nozzle, as it gets to the nozzle, the little feature inside there splits the filament strand into 3 smaller strands where it can more easily get to the core of each of those smaller strands of filament and melt them faster. So these are not cheap nozzles compared to the other ones. You can get like 40 brass nozzles for, well, probably actually you can get more than that for this price. But these are not hardened steel, I don't believe. I think these are more of the nickel plated brass, I think. We'd have to check and see if it says anywhere in here. Oh yeah, here it is. Nickel coating applied to our brass nozzles. So they're not hardened steel, but they are intentionally trying to split the filament into smaller strands so they can melt the individual small strands faster than it can melt one larger strand. And it's the core, the very core of the filament that's going to be the last part to melt. So thank you, whoever Maker Mind Nexus. Thank you. There's like, oh yeah, we're going to do some of the calibration tests. Maybe not from Orca though. So these are a way. The nozzle we put in here is just a plain Creality one. It does not have this feature inside. But those are 2 things that, without changing a whole bunch of stuff, you could help increase your flow rate. All right. Let's see what we've got here. So we're back over here. We were in Cura, weren't we? We were over here. So what we need to do is, let's just do some sort of print just to see what we've got, where we're at. So I have the part for calibration add-in extension in Cura. You may not have that. If you don't have the part for calibration extension, you can go over to the marketplace, and it is called the marketplace, like you're buying stuff, but it's just to download. Would the 3-way splitting method wear down very fast? It probably would if you were printing something abrasive, but that kind of, let me make sure that we're clear on one point on nozzle wear and abrasion stuff, like the hardened steel nozzles, because I think this is a pretty common misconception. So let's just say we have a generic nozzle here, and we'll give it some kind of shape. So I think I might have done this before, but I don't remember if I did it in this class or not. So there's like a cross section of your nozzle that could be any material, and most people think that you are printing a abrasive material like a glow in the dark or copper fill or something like that that's got some kind of gritty thing in it, doesn't actually matter if it's gritty or if there's just something in there, because even wood feel that you wouldn't think like sawdust would be that kind of abrasive, but anything that's got a filler in it, some of them are worse than others, but it's got some kind of filler. Most people think that it's kind of an extrude hone type of setting, where, not setting, but fault, where what is going on is your filament comes in here and it actually eats away like here and makes the nozzle larger. But that's actually, it does do that maybe a little bit. Really what the problem is that this part of the nozzle is basically rubbing across all the print all the time, so it's like grinding it down, and so you actually lose, you know, this part of the nozzle, and that's where the hole gets larger, the nozzle diameter gets larger and larger, and on the brass filament, brass nozzle, if you're printing something like glow in the dark, most of the wear is actually coming from this direction, not because the filament is eating it from the inside out. So the question was, would the splitter in the Bondtech type of nozzle, would it wear out fast? I don't think it's going to wear out terribly fast compared to the end of the nozzle printing on whatever the material is. Oh wow, cool. So there's a bunch of these videos. I usually do this class every summer for the past several years, so you can go back in time and get all kinds of different things. So that blade, the little blade inside there, I don't think it's going to wear out very fast compared to the end of the nozzle getting worn off, because those aren't hardened steel. They're just coated, which is what we do have in the printer right now too. I just don't have the little blade inside there. I do have some of those nozzles, and I have printed with them for a while, and I have not seen, as long as you don't print abrasive stuff, you know, as long as it's just regular filament, then I have not seen the inner blade wear out. I'll have to check and see if those are an issue. I haven't seen it before. Let's throw something in here. Let's just do a cube. Nothing fancy. So here's our cube. Let's go check our slice. So we've got 0.6 millimeter layers. That's fine. Let's only do. I don't like only doing one wall unless we're doing a flow test. Maybe we could do that. We could do a flow test here and just see, are we getting the 0.8 millimeter line width out of this thing. So we can do that. Top and bottom layers. If I put 4 layers like I had been doing, that's going to be over 2 millimeters thick now. So I don't think we need. We're not going to do any top layers on this one. We're going to make this like an empty cup. We're going to do. Let's do 2 bottom layers just to have 2 of them down there. I don't generally like doing just one, even though it's really thick. Infill density is going to be 0. This will be a empty box. So we are asking it to print or melt a lot of material. So I normally print at 205 for PLA, but now that we're trying to melt a lot more, let's bump that up to 210. That may even not be enough. Build plate is fine. Print speed 50 is kind of slow, but we'll call it good for now. We do need cooling. So cooling is an interesting thing with the bigger and bigger chunks of plastic that you're putting down. You might find that you actually have to do less cooling, even with PLA, because if you cool it too fast, it'll cool the outer parts, and then the inner parts are cooling later, and it might cause some warping issues. We'll just have to experiment with that. I'm going to leave it at 100% cooling right now, but it can cause some issues with the laying down really chunky lines of filament. We'll have a skirt. I just noticed that I've got a build plate on here that I've just got this one. Let's. Oh, that's the PEI side of it. Okay, so that might be okay. All right. Let's slice that. Preview it to see, make sure we got what we wanted. Yep. And how long is that going to take? 6 minutes. That's not very long. All right, so save the disk. It'll probably take longer to heat it up. We'll just save this as 8 box and put it on the desktop. So over here in Clipper, what you do is you go to your G-code files and you upload, and you find, I'll put it on the desktop, and I can put it right there, and then you just click on it and print. Actually, there was a button I could have uploaded and printed. Oh, hold up. I think the last thing we printed on here, no, it's fine. So it is going to heat the bed to 70. Remember, we were trying to do those heat transfer things, and so I had the bed a little bit hotter. This is not normally what you do. I just have it kind of hacked together right now. But in the Clipper version of doing things, the start G-code mostly exists in Clipper, and what I'd want it to do is grab whatever temperatures I set in Cura and plug them in, but right now it's grabbing these default numbers. So 70 for the bed and 205 for the extruder. So we actually want it to print hotter than that, and I don't really need the bed at 70. It's going to start with 50 though, it looks like, so maybe it is finally working the right way. I've already cleaned off the bed over here, so I wiped it. I usually have a little spray bottle of isopropyl alcohol and some kind of microfiber to clean these things off with. This is not the bed I normally print with. I don't know where the normal bed is. I put it somewhere. But normally I would print on a textured PEI. But with PLA, this PEI, this is an older SaneSmart textured on one side, and the other side is completely just steel. And that one I was using for those heat transfers. Which, by the way, I do have the other things we were going to try. I've got the actual clear transparency overhead sheets, so we'll try printing on those, and I've got the water slide decals, which don't really have anything to do with 3D printing, just another way to get images onto 3D prints. Alright, so looks like it is honoring the Cura values right now, so that's good. It is heating the nozzle, in case you want to look at that. It's heating the nozzle up. See if there's anything going on over there. Nope, all right. It does seem to be heating the nozzle slightly slower than it was before. Maybe our PID tune is trying not to overshoot. I use the Ender 3 for this series of classes mainly because you can take any part of it apart and change it however you want to. They're not especially cheap compared to some of the stuff you can get that probably has a lot, or does have a lot more features, but I like them for, like, what you see is what you get. There's no hidden stuff in here. I mean, you got a control board down there, but everything's, you can change anything. We've already changed, the direct drive from the Bowden tube. Everything's accessible. It's just extruded aluminum and some hardware, and so I do like that if you're learning about printers. Now, if you just want to print something, get you a little bamboo A1 or whatever and just print. But if you want to learn about the printers, get one of these kind of printers, and you can change anything. You can add a dual Z if you want to. You can add a bed sensor. You can add a direct drive. You can add a lighting kit, and it's just way more about the learning part than the printing part. So I still use them for the learning part. All right, so I don't know what we're doing here. Oh, now it's going to heat up. Now it's going back to the defaults of the 70-degree bed temperature, and I assume it's going to drop the extruder down to 210. I'm not sure why it's doing that. I'll have to dig into the printer config and see what it's doing. I suspect it's in Cura, actually. Let's see. While it's doing its thing. Let's see. No, it's not in Cura. Okay. Something about the way the clipper is operating. It's doing what Cura says, and then it's doing what it thinks. Maybe I should just erase the defaults. I don't know. So now it's changing the target temperatures. They're fine. Part of what I'm doing. Printer rehab. Yes, that's a fun thing. And there's a lot of old printers out there that you can get. And if you will get a used off of eBay printer, you can get a pretty cheap printer. Or these things, without all the, without the bed sensor and without the direct drive, these things go for super cheap on Black Friday. This one was $99 on Black Friday. But yeah, if you'll get a project printer, you can get those off of eBay pretty cheap. Or a lot of times people will give them away because they think they're not good printers. These can print as well as any printer, but maybe not as fast as any printer. In fact, the very first printer, look how thick our skirt is. The very first printer that I guess I didn't own it. It was the school's printer, but it was a Stratasys 1200 SST. So this was a big name company, and this was back in 2002 or so. And that thing cost $75,000. This prints as well as that thing did back then. That one doesn't print at all now, but these are perfectly good printers. They're just slower, and you might have to do some more maintenance or more work than you would on something like a bamboo. So I don't know if you can hear it or not, but there's a popping sound when it's printing. So that popping sound can be a couple of things. One, it can be I'm printing too hot, and it's well, maybe not the too hot part, but it is has moisture entrapped in the filament, and it's actually boiling off as it's printing. I can hear it pretty easily because it sounds like Rice Krispies. But the other thing it could be is that it is trying to supply filament, and it's having gaps in there, and so it's like little air pockets that are escaping from the nozzle because it can't get enough filament out of the nozzle for how much the demand is. It's kind of stopped now, so I think it was more since the first layer is really close to the bed. I did not adjust the Z offset, but yet I'm asking it to smash down a really thick layer, and it might have been that. In the walls, I don't hear any popping, so I don't think the filament is moisture laden. And I think it's able to supply the demand. I think it was just the nozzle was too close to the bed. Oh, you can hear it? Yeah, so that sound is usually, you got to see what is that sound about, because a lot of times it's your filament has moisture in it and it's the moisture boiling off. That is not something you're going to fix without, drying out your filament. I showed off a filament dryer. Oh, it's been a couple of weeks now. But they do have some relatively affordable filament dryers. So particularly if you're in a really humid area, PLA is not normally a problem. This is PLA, but even in the really humid areas, you can get moisture in the PLA. Like I said, it stopped. The snapping sound stopped. So I think it was more. I was just so close to the bed that it was just squishing filament everywhere. Let's see if we can get lower down there. You can kind of see what's going on. It's always hard to see under the nozzle what's going on, but did I do one wall? Yes, I did one wall. Look how thick the walls are. Where are my calipers? There they are. So having some set of calipers with printing is generally good. One, for stuff like this, I can measure. I ask for those walls to be 0.8 millimeters thick, so I can measure how thick are they. Now, a single wall print like this, it kind of will tell you, but there are different things that happen when you ask for two walls side by side because they overlap a little bit. So don't take it for like the hard truth that if I get 0.8 millimeters that everything's perfect, because it's not interacting with any nearby infill or walls, and so there could be some changes we would need to make, but it should tell us if we're anywhere near perfect. And it's 90% done already. I was going to go over to our oh yeah, okay. So while it's finishing up, this is Cura. So this is the preview. Normally your preview shows you line type like this, but once you're in your preview, this is for Cura. Other slicers will do similar things and different buttons to push, but you can ask for a lot of different views here, and so one of them is flow, and it will show you the flow rates that are being asked for at different parts of your print. And so the bottom down here where the popping was occurring, it was asking for 12 there's the units, cubic millimeters per second. It was asking for 12 is a lot in general. So that could have been contributing to our popping sound, is that down there it just couldn't deliver the filament that was being asked for. The rest of the print was 4.8 or so, and so it could probably do that. All right, so it's done. There's our, let's zoom back out a little bit. There's our little box. Wow, it's stuck down pretty well. Let's see if I can get it off of there. All right, so there it is. We'll get the skirt off of there later. So definitely have some Z-seam. I don't know if it will focus on the actual part here. Focus on that. There you go. Definitely a pretty major Z-seam. Also, I'm noticing it didn't supply everything it needed right there. There's a gap. Also, look at the bottom. There's gaps between the actual bottom and the walls of the bottom. They didn't get filled in. So there are some flow issues in this. It is trying to do something that, for whatever reason, it just can't do. Let's see if I can get it there. I don't know if it's... Maybe I should have picked a different color filament. There, turning the light on kind of helps. But there's little gaps between the wall and the floor of the thing. That's a flow rate issue. It could be a overlap issue in the slicer, like they're not overlapping far enough. But since we were hearing the popping sound, I'm kind of thinking that it was asking to flow too much, and it just didn't do it. The walls look decent, except for, look at the corners. The corners are really struggling there to maintain a sharp corner. Our Cura, telling it that this is going to be a perfectly square corner, not rounded like what I've actually got. So that could be I've got some speed issues. I've got some cornering issues that I got to deal with. The Z seam, super strong Z seam. So I don't remember, or I don't know what the retraction settings are, but it might be that it has retract on layer change turned on. And so since I'm dealing with so much volumetric flow out of the nozzle, when I change layers and it retracts, it can't get enough filament back before it needs to start again, and I'm getting this really strong Z seam, and so I might have to do some tweaking on the extra restart on, or extra filament on restart or something like that. I don't remember the exact phrase that Cura uses for it, but add a little bit more filament when it restarts a layer, because it looks like it's got a huge gap in it. Alright, but it did print. So let's check out what our dimensions are. So I don't normally do a yeah, there we go, digital caliper, but it's easier to see on the camera what's going on. So I gotta zoom out some though, because I can't keep it all in the frame. There's our little pie. I guess I could move this back up to here, except I don't know where it came from. That's fine. The border's off. We'll deal with that later. All right, so we wanted these walls to be 0.8 millimeters. So what I normally do on these is I measure 2 times per side and take the average, because they probably will be different. But oh, wow, 0.9 on that one, nearly 1 millimeter. 1 millimeter there. I may have to check the slicer. Maybe I have it set to 1 millimeter for the line width. 9.4. I'm not at over 1. Oh, that's right at the corner though. Let's get closer to the middle. 0.961. So that average is, I didn't average it, but it's close to a millimeter. So let's go back to Cura and see if I actually wanted that. I don't remember. I didn't change the line width. Normally the line width in Cura is just the same as the nozzle diameter. Yeah, so 0.8 millimeters. So it is over extruding. According to, I wanted 0.8 millimeters and I'm getting like close to a millimeter. Now that's good that I can get these nice big walls, but that might give us some problems, and it might also be an issue with our flow not being able to supply what it needed to do in the bottom layer. So it should not have been that we have to change E-steps on this. Changing the nozzle really doesn't affect your E-steps, but I don't know when the last time I did the E-steps for this printer. So the E-steps, remember, over here somewhere you've got a stepper motor that is feeding filament into the hot end. The E-steps are the extruder steps, or how many steps of that stepper motor does it take to extrude a certain amount of filament. I believe that these are set correctly. Technically, just for anybody that's a clipper person, in clipper the E-steps are called rotation distance, so they do have different names in different firmwares, but it's the same idea of I've got to calibrate how much filament comes out of here based on how much the stepper motor turns. So that's the idea. It could be that I'm not calibrated right. Why don't we check that really quick and see if we're anywhere near that, because I am getting way more filament coming out of the nozzle than what I'm asking for. So how we can do that is we got to heat up the nozzle. So I'm going to go to, I was printing at 210 or 205 for most of that, so let's heat up to 210. And then over here, while that's happening, we'll have to go up some. Now this is a direct drive, so the filament is coming into the feeder and going straight into the hot end. Bowden tube is a little bit different. The feeder is mounted remote and there's a tube, the same idea applies, but you have to measure it differently. So what I'm going to do is I'm going to find something to write with, which I see nothing around here. Let me find something. All right, not the ideal tool, but found an expo marker. Oh, this does remind me though. So if you have white filament that you are not particularly caring how this comes out, but you just want some different color, you can literally draw on the filament with a marker, and that color will come. It'll be, you know, diluted, but that color will come out in your print. So you can get some pastel looking colors, maybe not an expo marker, you know, a dry erase marker, but a Crayola marker or anything like that. You can actually write on the filament, and you won't get patterns necessarily, but you'll get that color to come out. In fact, there's one, I haven't seen it in a while, but there was one adapter that would sit right here, and it would hold like a couple of markers, and they would just draw on the filament as they passed through it. So it's a kind of fun thing. It doesn't have a practical reason, but kind of fun. All right, so I'm going to mark a mark from here. I'm going to do 100 millimeters. Right. Let's see, let's get it all lined up. Okay, all right, I can see the mark. I don't know that you guys will, because it's super light, because all I could find is a dry erase marker. So there's a mark right there. And so use something you can actually see. Now it's heated up, so I'm going to ask over in here for 100 millimeters of filament to be extruded. You can do that on your control panel down here, directly on the printer if you want to. I'm just going to do it over here. So I'm going to extrude 100 millimeters, and I'm going to extrude. Normally you actually slow down the speed of how long, so but I'm already at 3 millimeters per second, so that's relatively slow. All right, and then it's going to extrude, and what I want to happen is my mark to end up right where I referenced it from. If it does not, then I'm actually over or under extruding. So let's see. Or, oh wow, did I actually? No, that was 50. Sorry, because I clicked out of it. So that was 50. Let's do another 50. I was about to say we were way off, but it was way under extruding. It's actually going to be pretty close. All right, so if it over extruded, it was by like a millimeter. So technically we might be over extruding. I don't think a millimeter out of 100 is like 1% is going to create that big of a difference in our wall thickness. So I don't think our E-steps are terribly far off. Well, our rotation distance is terribly far off. So that leads us to working on our slicer. So in our slicer, I've got flow pulled up here, and I don't want to just drop down, you know, whatever the ratio was, 20% or whatever. I would probably go down to maybe 95% and see if that gets me closer to my 0.8 millimeter wall thickness. I would also, you know, let's see if we can figure out, I don't normally like changing multiple things at once and then testing. You really should just change one variable, test that, and then change a different variable, test that. But let's also see if we can do a little bit about our Z-seam. So I think our Z-seam is probably over in retraction, and it is enabled. Oh, well, so for one thing, for when I reset it, I guess, when I change the profile, this is a direct drive printer. It does not need 5 millimeters of retraction. That's for a Bowden tube. It needs like half a millimeter. So that might be our whole issue on the Z-seam. Had I not seen that, then the thing I was talking about was retraction extra prime amount. So there's none. That's what I was going to change. But now that I see it had 5 millimeters of retraction, that's probably the actual problem. So now we're about out of time. But I would slice, print again, and see where we're at. I'll probably tune a little bit more, and we'll come back on Monday and see where we're at. But if there are any, I don't see any chat comments about what to do next. But I think I'll get this thing dialed in, or at least better than it is now. We'll do some prints. We've got some cool filaments. We've got this champagne metal filament to print with. Oh, the camera froze again. This champagne metal filament to print with. That could be cool vase type material for these really thick layers. So that might be interesting. And we will do some maybe these upgrades with the dual Z, the light bar, stuff like that. I will plan to try and find, maybe I can just reinstall Clipper for this printer, or go through the motions of installing Clipper, because there's a couple of little pieces that are maybe not as straightforward, but most of it's pretty straightforward for getting Clipper running on your machine. All right, we'll be back Monday, 8 o'clock, and let me know if you have any things you want to see. Send them in the Discord or send an email or whatever. And we've got, like I said, maybe 12-ish, 10 to 12-ish topics left. So if you want some particular thing or want to recover some particular thing, then let me know. The only one that I know that's coming up is finishing. So different ways to finish the parts. We still have a few things on our X30 to model, mainly the front landing gear, and I need to actually print the canopy in resin. And we're getting close to, we never modeled the stand. We kind of did the topology optimization, but we never actually were satisfied with that. So we need to make a stand. Oh yeah, thank you. Yes, no problem. I'm glad hopefully it will help a little bit. All right, I will see y'all on Monday.